So the 5.5 notes, properties of logarithms, you should have already printed out that PowerPoint sheet that has the 3 slides on it. Properties of logarithms is what we're going to be talking about today. Just going to work through a few examples, as you can see on this piece of paper here. And we're going to, through the examples, I'll be illustrating how we use each of the properties of logarithms. Specifically, as we start on number 1 here, log base 7 of 7 to the 20th, we refer to property 1a, which states that the log base b of b is equal to 1. The one thing that doesn't get pointed out here is that the exponent of that b in the argument is 1, and that's why that's a 1. Okay? In other words, if by chance the exponent was a 3, then this would have a value of 3. Log base b of b to the anything is the anything, and so that should be pointed out. And why is that true? Well, because the flower power, b, the base raised to this number here, is equal to the argument. Okay, and so one thing also to note is that when you oh shoot, I didn't mean to erase all that. Hold on. One thing to note is that when the base here, let's get a different color. When this base is the same as the argument, the base in the argument, then it's as if virtually the log base b is canceling out or nullifying that base b right there. So these guys just go away, and all you're left with is the exponent in the argument. Okay, so all of that being said, all that confusing writing over there, noticing here, let's look at number 1. The base is 7. Okay, so the base is 7. Well, guess what? The base in the exponent, or sorry, the base in the argument is also 7. Also 7. So therefore, the log base 7 of 7 to the anything is just the anything. So 20 is the value of that log. 20 is the value of that log. Okay. Now there's another way to look at it. Some students are like, I'm not really sure what we're doing here, but let's look at it a different way, the way that we did it back in section 5.4. If you don't know the value of the log and you're unsure about that property, then you can just let x equal the log. Okay? And then when x is equal to the log, you can convert it to exponential form. And when you convert it to exponential form, you get 7 to the x is equal to the argument, 7 to the 20th. And therefore, x has to be equal to 20 because you equate the exponents. And x being the value of the log, the value of the log is 20. Okay, so it's just a lot quicker if you can just remember the property. If the base of the log and the base in the argument are the same, then the exponent in the argument is what the value of the log is. Okay? Alright, so let's look at number 2. ln of e to the radical 7. Maybe you just said, oh, that's just radical 7. Well, you're right. That is just radical 7. Why is that? Because ln is the log base e. Log base e of e to the anything is the anything. So there you go. Okay. Well, let's take a look at what property would this be. This would be property number 3. Okay, so if we look at property number 3, we see that the difference of the logs, now they have to have the same base, so be careful with that. The difference of the logs is the log of the quotient. So the log, doesn't matter what the base is. In this case, the base happens to be 4. And so the difference again of the logs is the log of the quotient. So the log of the quotient is the log of 24 over 6. And then you can simplify the quotient. That's okay. That's free game. Anytime you have a quotient like that, you can go ahead and simplify it. 24 divided by 6 is 4. And we already know that based on properties, the property 1a that we've already talked about, that's equal to 1. Log base 4 of 4 is equal to 1. And so this whole thing has a value of 1. Plain old boring 1. Alright? Now, we're going to look at property number 4. For example number 4, we look at property number 4. Is that right? No, it's not right. It's not 4. It is 5. So property number 5, we have a base raised to a log with the same base. Okay. Well, property number 4 says when you have, or 5, when you have a base here, b, to the log base b of some number, well, guess what? It's just that number. So the base raised to a log, when these two bases are the same, then these cancel each other out. Okay, so raising a base to the log of the same base basically undoes what's being done to the argument, and so you just get the argument. Well, how does that relate to this? Well, first thing we should note is that we have the difference of two logs, and so we want to simplify that first before we do anything. Okay, so we have the log base 10 of 30 minus the log base 10 of 5, and so the difference of the logs is the log of the quotient. So 30 divided by 5 is the new argument, and so we get 10 to the log base 10 of 6. Well, again, it doesn't say 10, but you know that when you see log without a base sitting there, that base is 10. And so we see that we have the base, the original base here, and then the base of the log, and those are the same, and since those are the same, they virtually cancel each other out, and you just get that 6 is just left standing all by itself. And that's it. So that original expression that we have here in problem number 4 has a value of 6. That is totally simplified to 6. So let's take a look at the second section of problems. We have, these are kind of, I call puzzle problems. We've got the ln of 2 is equal to a, and that's lowercase a, and the ln of 5 is equal to b, and we're supposed to use properties to express these logs in terms of a and b. Okay, well, we have this 10, and we need to express the 10 in terms of 2 and 5, so these are helpful problems to just help us practice the properties of logarithms. We know that we can write 10 as the product of 5 and 2, okay, and the log of a product is the sum of the logs. Okay, and well, now we have the opportunity to replace our ln of 5 with b and the ln of 2 with a, and then we're done. So you just want to get the arguments in multiples or powers of 2 and 5, and so that we can express these logs in terms of b and a. Okay, maybe you want to try these on your own. We've got the ln of 20, and we know the ln of 20 can be factored as 2 squared times 5. So this is kind of nice. We get to practice another one. And ln of the product would be the sum of the logs. Ln of the product is the sum of the ln's. 2 squared plus ln of 5. Okay, and then there's that other property. If you look at your property sheet, we've got property number 4, which says that when we see this exponent way up here in the argument, we can bring that exponent out in front, and we can write that in terms of this exponent 2 multiplied by the ln of 2 plus the ln of 5. So we have 2 times the ln of 2, and we need the ln of 2 by itself because the ln of 2 has a value of a. That's what was given to us. Now there's a big mistake that students make all the time, and I don't want you to make this mistake. This is called, this is 2a, not called, 2a plus b is the answer. Okay. Now I should note, and you should note, that the ln of 2, so let's write the word note right here. Okay, this is the mistake students make, so pay attention. The ln of 2 squared does not equal the ln of 2 quantity squared. Okay, see right here in the argument, only the 2 is being squared. Okay, so if the ln of 2 is not being squared, then you would not want to say that this is a squared. That's the mistake students make constantly in this section, because they're not really paying attention. So I know you're not going to do that. You're going to pay attention. And so when you see an exponent above the argument or in the argument, you're going to bring the exponent out in front of the ln, and then this is the way we did it up here. Okay, the way we did it right there. Understand? So bring the exponent out in front. Then you can substitute the a for the ln of 2, and everybody's happy. Okay? Let's take a look at number 7. So number 7, we see we have the 5th root of 20, and we're not really happy about that. So let's write this as ln of 20 to the 1 over 5. Okay? Well, 20 to the 1 over 5 is fine, but we need to, again, bring that exponent way out in the front. Okay, so if we bring the exponent out in front, we can write that as 1/5, multiply that by the ln of 20. Okay, well, 1/5 times the quantity, ln of, remember what we just did, we had the ln of 20 just up there, so we're going to rewrite the ln of 20 as 2 ln 2 plus ln 5. Okay, and again, once we get the ln of 2 all by itself and the ln of 5 all by itself, we can go ahead and substitute in the values of a and b. So we have 1/5 multiplied by the quantity 2 times a plus b. And we're done. That's it. So that's the left half of this page in less than 12 minutes. So we're going to do one more video, hopefully, and finish up the rest of these notes, and then you guys can do some practice problems online. Okay?